You're tuned into Conversations with Remarkable Engineers. I'm your talking tour guide, Don Fernando. Let's explore the blueprints for tomorrow, today. In a world where the echoes of ancient wisdom sometimes blend and inform the work of cutting-edge modern builders and designers, we converse with those who shape the future with their hands and minds. Today, we delve into the thoughts of a remarkable individual, Korkut Onaran, a visionary who walks the line between the past and the present, crafting solutions for tomorrow. Korkut Onaran isn't just a designer, he's a storyteller whose tales are etched in the concrete and spaces of the edifices that he imagines. With a career spanning continents and disciplines, Dr. Onaran stands at the intersection of urbanism, architectural, and practical sustainability, advocating for designs that speak to our heritage and future needs. I recently spent a week working with Korkut Onaran at his atelier in Boulder, Colorado, where he's an architect, planner, and professor of urbanism at the University of Colorado. The afternoon I recorded our conversation, we were at his home, casually talking about the architectural program requirements of a new client. This client wanted a house that he could live in comfortably in hot, humid Houston, Texas, without air conditioning, a very tall order. So join us as Dr. Onaran takes us through ideas of innovation, resilience, and the art of re-engineering the modern house on ancient principles. From the ancient courtyards of Greece to the bustling streets of modern cities, discover how the past and the present converge in the mind of this remarkable engineer. So how would you make a house? You were talking about the Greek style houses that live sort of year round in hot, humid, cold times, etc. And you were talking about like the courtyard concept and creating breezes.
Yeah, ancient Greece has very, let's say courtyard, but the courtyards have extensions, right? Like a cross. Now, this is the amount of openings. So openings would be really small. This is the area directly open to the sky. The whole thing is actually protected. In some of these, let's say there's a pond, people lie down here. Here they have discussion room. And then the other rooms, let's hatch them. These are the ones you would go and live in winter. So the winter living is really limited. And in the summer living, this whole thing opens up. Now, let's say, this is just a schematic. I mean, they are much more organic and irregular usually. But there's another. So basically, what you're seeing, the cross is outdoor. And there's another outdoor, and then there's an outdoor. And these walls would have small holes to get the air through. So there's this ventilation all through here. But the whole idea is that the house lives seasonally. Season to season, you need to adjust to the new season. In winter, it's getting cold. You just insulate these interior areas and don't live in the courtyard because it's cold. But in the summer, the whole thing opens up and you live the whole thing. So, in a lot of the places where there are conflicting climatic conditions, you just adjust to the season. You change the house. There are a lot of removable awnings, removable panels. You insulate certain areas during winter and you take them out in the spring.
Ancient Greek homes were built around a courtyard or garden. The walls were often made from wood and mud bricks. They had small windows with no glass, but wooden shutters to keep out the hot sun. They had little roofs over some of the exterior courtyards to keep out the rain. The Greek word for family was oikos, which was also the house's name. So house, family, they were all the same. Houses followed several different types. Many of the earliest houses were simple structures with just 2 rooms connected by an open patio. Larger homes had more rooms, sometimes 4. The patios were covered with a roof. But life was lived primarily in the courtyards. You talked about how the main problem, we were talking about mold. And, I'm working with a fellow that wants the homes that don't rot, don't mold, never do this. And we were saying that mold just happens. It's in the air. The mold spores are in the air. Doesn't matter what you build with.
Mold gets really tricky when you have cavities, when you're enclosed, airtight places. And
Right.
when the mold gets in there, they flourish there. So in a humid climate, the rule of thumb is that you need to be able to open everything and air it, the walls included.
Mm-hmm.
So you need to insulate a wall. You design some panels that can be removed when you need to dry the whole thing. We were flooded, and
Yeah.
and I came up with that idea. That is to say, every time there's a flood, they put all the drywalls out. We used really high baseboards,
Mm-hmm.
and then left the drywall shy, so that if we're flooded, you take the baseboards and you air the.
Mm-hmm.
So that's the principle of adjusting to the season.
Mm-hmm.
Imagine you have ways, the panels to remove the whole drywall and open the whole wall.
Mm-hmm.
You wouldn't have any more problem.
Or you could leave it exposed like they used to do.
Yeah, they used to do it. But in the winter, all of a sudden, you need to insulate. You put it back.
Yeah. How do they do it? You said in Japan. It's very, very humid.
Well, that's an extreme condition where, there's a really conflicting, a really high amount of humidity, but cold winters. And you go to those Japanese villages, they have still paper walls.
Mm-hmm.
In the winter, they do, they wear a lot of clothing. They put fire in the middle of their house and they live through. Because if they didn't do otherwise, if they insulated and tried to airtight, humidity is so high that they would be in big trouble with the mold. So that's why they choose, in order to survive, we need paper walls, and that's that.
Mm-hmm.
And we'll deal with the consequences.
So they in order to not have mold, they get cold.
They get cold, exactly.
Yeah. So,
but that's an extreme case. And nowadays we have technology and such. We don't need to suffer through the winter. We may adjust the house to deal with the cold.
Yeah, you adjust the house to deal with the cold through heating and air conditioning.
But
yeah,
the users need to be trained for that. The users need to understand the way the house works.
So this gentleman's concept of the mold-proof house comes from his experience living in a hot, humid climate in St. Croix in the tropics. Yeah. I assume his house wasn't in the middle of the jungle. I assume it was on a hill or in an area where there was... So he talks about breezes and air and sunshine and all that. And so we were talking about the fact that if you do have it, like you could build the whole house out of wood, right? Yeah. But you leave the studs exposed.
Yeah, you can do that. One thing I would say in those kind of conditions, if they are really cold winters, and what I'm saying is that I'm not going to use any air conditioning, any heating. You don't need to be black and white.
No.
Get 1 or 2 small rooms, air conditioned.
Yeah.
And heat it. You keep your electronics, your computer, etc., so forth, because in a hot, humid, tropical environment, there are bugs and so they eat everything. What you don't need to do the whole thing that way. Right. If you have 4,000 square feet, get 400 square feet of a room, well insulated, etc., so forth.
Mm-hmm.
But when you have to live there, you live in that space for a week or 2 or a month.
Yeah.
But then the life goes back to what it was.
Well,
that's another thing I see a lot in a lot of these kind of places. That's conflicting climates. Life adjusts to the conditions. Yeah. And so is the physical environment.
Well, and you could definitely do that in Houston. Like I was pointing out, well, how are you going to have this house without insulation in Houston when it gets down to 15 degrees for a week?
Yeah. You don't need to do a house.
Yeah.
You do a room or 2. It's like that's another way to have it,
And also you might also just sort of lean the house to saving energy in the hot climate, and maybe it's a little bit wasteful. You need a little excess heat in the winter during that 1 week.
6,000 square feet house.
Yeah.
And why are you heating this whole thing?
Yeah.
Right? If you were trying to save energy, just heat a room or 2. It's like...
Well, you could do that with the area, with zoned.
Yeah. I'm exaggerating, but that's the whole idea. That is to say, you go to some of these Mediterranean towns in the smack middle of the winter, the living areas shrink.
Mm-hmm.
They live in tighter areas. That's, you know.
Yeah. Well, we did that in Buenos Aires because we had a big open courtyard, and all summer and all most of the time I was outside playing. We went roaming, but in the winter, in the cold winter, we were like huddled in one room watching TV with the propane heater on.
Yeah, I mean, that's energy saving.
Yeah. I mean, it wasn't a modern way of living, but it was the way we lived.
That's
how we lived.
There's a lesson to be learned there. That's what I'm saying.
Yeah. So there is a relationship that can be done, and see, the other thing too is that it's. I mean, you can, for example, it'd be easy to. I could specify exactly the house that this guy wants. For example, I mean, very simple. We have concrete masonry units on the interior, painted. That's the only finish on it. Mm-hmm. Insulation, and another layer of concrete masonry unit on the exterior. 2 layers. Insulation in between, a sandwich, but an impervious sandwich. You insulate it with foam. Bugs don't eat it. Nothing happens to it, and now you have it. The only problem is the cost of that building becomes quite high. And
again, I mean, if it's a humid and hot summer, my inclination is the majority of the floor area of the house should be open.
Yeah.
Outdoors, almost. It's like that kind of openness.
Yeah.
And that saves energy. That saves everything. That saves material. You don't need to insulate everything.
Yeah. Well, the other part of it is that his sites are in the woods and basically in swamps. I mean, a lot of swamps. And I know we live on a swamp. It gets very humid, and because of the swamp.
Yeah.
The water in the ground evaporates in the heat of the day, and the humidity becomes very, very high.
But in the courtyard thing,
if
you can design it well, you have the breeze funnels.
The cross ventilation,
That makes a huge difference between the outdoor temperature and the courtyard temperature. Courtyard is a very comfortable place to live if you design it well.
But you refer to it you don't refer to it as cross ventilation, and you call it what did you just call it? Breeze breeze tunnels or something like that. Breeze funnels. Yeah.
Funnel means you really squeeze the air, so it needs to be narrow. Those New Orleans
shotgun.
Shotgun.
Row homes. Okay.
Row homes. You remember, you come from the street through a really narrow corridor and opens up to a. This is all exterior.
Yes.
Opens up to a courtyard.
Yes.
That's a funnel.
Okay.
There's courtyard, there's street, and in between the air movement happens in a very limited place. If you open that up, you're not going to get that. So that's why I call it funnel.
Okay, funnel, because it isn't just having cross ventilation. Like a plaza would not be this, because it's open.
Yeah.
And so what you need to do is narrow. You have to create the wind. There's a combination of architectural elements and, of course, technological. You're going to have some air conditioning, some heating, and some layering. The conflict I see is that we have the IECC, the International Energy Conservation Code, and the whole point of the code is to reduce the consumption of energy. So they require a lot of insulation.
Yeah. Give only a small portion of the house as interior space to be insulated. You pass the code.
Right.
You don't need to have 6,000 square feet or 4,000 square feet of it past the code.
Right.
It's exterior. Courtyard, veranda, whatever you call, all those prototypes don't need to be qualified as insulated space. Your house, actually, in their mind, is, let's say, 1,000 square feet.
Right.
And it's easy to insulate that. Yeah. And like I said, in the modern living, you have computers and music sets and such.
That require dry air.
Yes, smack middle of that 100% humidity. You need to protect it.
Yeah. And that's interesting. And sleeping quarters and such can also be isolated such that you can condition, for example, the sleeping quarter in the evening if you wanted to, but not the whole place.
I mean, if you have a sleep problem, the courtyard is not cutting you. You go up, get the breeze. That's not cutting you. You really need to sleep. Well, one room is air conditioned, you go and sleep.
Yeah.
But again, there's a difference between 4,000 and 400.
So could you design a house that's in a forest, near a swamp, or maybe even on a swamp. In the Houston climate, hot, humid climate, mixed climate, because it will get cold in the winter,
Yeah.
prone to flooding, so that these flooding things, where you can recover quickly. Like they used to make these Mac houses or something in Florida that were just cement masonry units, no insulation or anything, just cement masonry units with a terrazzo floor. And when they flooded, you lost your furniture, but then you cleaned it up and the house was fine. So can you imagine designing such a house, at least conceptually? If
Yeah.
That would work.
I mean, the future users need to be on the same page, of course.
Yeah, because it's not
but
it's also not a conventional house. What people expect is a house if you got 6,000 square feet, you got 6,000 square feet insulated and air conditioned and the whole bit.
Exactly.
So then I say yes. I mean, I was talking about the Navajo. They had two houses. That's how they had a winter house and a summer house.
Yeah, that's a very common thing as well.
And that's a very common thing throughout the world. Right. So our people, in Rome, right? They had the famous beachside areas for the summer and all that. But modern people don't live that way. Or can't afford to.
But also that's the seasonality. That is either that, half nomadic, or you really change certain things in your physical environment to adjust the season.
Yeah.
And they can be designed simple and.
I like a lot though the idea with a lot of outdoors in the house.
Yeah.
Because when we're not in the very cold season, we live out, we eat outdoors. We in our house in Houston, and so I like that idea because you can also enclose it with mosquito netting and all of that. It can still be outdoors, and it doesn't require air conditioning.
Well, I mean, if you look at this plan again, these alcoves actually, if you close the air movement,
right,
and put a fire in the middle of winter,
you're warm.
You're warm. I mean, that's the kind of thing.
Yeah, because those, they have that perforated block that's like a lattice and air that I can imagine the buildings being separated by a perforated masonry unit like that. Yeah. And then, and that's interesting, the idea of a fire in the middle, and then you could just close it off.
Yeah. In Bodrum, for instance, they have above each window there were 3 holes.
Yeah.
But you can put plugs in those and then close that air.
Yeah.
Because, in the winter, you get cold.
Yeah. That's interesting. Thank you.
But that's seasonal adjustment is important.